Thanks everybody for coming. I'm going to be talking about DBLS, or Databricks Language Server, which is our runtime-aware kernel-embedded notebook-native Python language server that we've built for Databricks notebooks. And starting off, a little bit about me. Hi, I'm Tamm. Most importantly, right now, since October 2025, my main job is being dad to my newborn daughter at home. But aside from that, I've been on the notebooks team at Databricks since May 2024. And before that, I wore various hats at Palantir for almost 6 years, starting off as a forward deployed engineer, working very closely with various customers, and really getting deep into the data science and data engineering world there. Later on, switching over to internal teams and doing software engineering as well. But I'm not the only one who has built DBLS. I also want to shout out the rest of our team, starting off with Stephen Mackey, who also gave a wonderful presentation here yesterday about reactive notebooks. And then besides him, Tobias, Jay, Dinglong, Ryan, Neelish, Jaipreet, Jason, Florian, Zhao, Bago, and so on and so on. So what are language servers? They're basically tools that provide IDEs or other coding environments with language intelligence tools. So the one that you're probably most familiar with is syntax error highlighting or linting. Those are nice little red or yellow squiggles that you get under your code if there is some sort of error or mistake. An extension of that is type checking. So besides just giving information about syntax errors, if you're going against typing in your code for languages that support typing, such as Python or TypeScript, then we can highlight those mistakes as well. Besides that, you have code formatting, making your code look pretty, go to definition or find references. So the idea there is you right-click on like a function definition, for example, and you can see all the places where that function is used. Rename symbol, same thing. It's like slightly more intelligent version of just global find and replace. You want to rename a variable or a class or something like that, you can do that. And then finally, code actions. Probably the most common code action that I've seen people use is the classic add missing imports to your code. So you're trying to use a function from another file that hasn't been imported. You get a squiggle, and there's a quick fix action that the IDE will add that import for you automatically. And the nice thing is that Python already has a pretty rich support for all these things. So for example, for linting, regular syntax error highlighting, linting, rough is a very powerful tool. For type checking, you have PyWrite, MyPy, Ty. For formatting, we have our girlfriend rough again, alongside other tools like black. For autocompletion / static analysis, so things like find references and rename symbol, Jedi is a very powerful tool. And then for refactoring, once again, Jedi, as well as another tool called Rope. But they're static. They look at just the source code, but notebooks inherently are dynamic. So when we started adding LSP support to our notebooks at Databricks, we very quickly realized that it turns out that embedding a language server inside of the Jupyter kernel is a very natural thing to do for notebooks, and it unlocks a whole bunch of cool new features, which I'll talk about in this talk. So quick plan. First, I'll do a very brief implementation overview of how we implement DBLS. Then I'll give a bunch of examples of the cool features that we get, thanks to being runtime aware and in the kernel. Then I'll mention some of the pitfalls that we saw while implementing this. Finally, talk about some of the future directions that I think this work should go towards. And then I'll answer any questions. So. The language server uses LSP, or language server protocol, which is like an open source standard, I think, maintained by Microsoft, for writing these language server tools. It's a Python process essentially that runs on a separate thread that is spawned from the kernel. So we built all this before soft shells were a thing. Now, when soft shells are a thing in IPy kernel 7, maybe we'll revisit this approach and use soft shells directly. And then inside of that language server thread, it can spawn off other sub-processes or processor threads to run all of these like wonderful tools like Rough. And then we either pre-process or post-process a lot of the outputs from these tools to add in that runtime-aware, kernel-aware magic. So most obvious example is a memory-aware diagnostic. So in notebooks, you could define a variable, and then delete that cell or comment that thing out. and your code will still run because that variable still exists in memory. However, static code analysis tools like Rough would give you a undefined variable syntax error highlight, which is kind of accurate, but it's slightly misleading because even though it's undefined in code, your code will still run. But we still want to give some sort of indication to the user that maybe you want to fix this because if now they terminate the session and rerun the notebook from scratch, it would fail because you no longer have that definition statement. So you can see we capture that undefined variable message. We see, but then we double check, cross-reference the memory state, see that, oh, this variable is present in memory, and we can update the syntax error highlighting message to be more accurate. Second example, smart handling of starred imports. So in Rough, if you have a from sys import star or some other star import at the top of your file, Rough will not give you any undefined variable lints down the line because it cannot deterministically say, hey, this symbol doesn't exist in memory space anymore because it doesn't know what symbols were imported from that package. But since we can check and we can know concretely which symbols are imported from that statement, we can expand on this, and we can still provide you undefined variable syntax error highlight lints while not giving them like false positive for symbols that are actually imported from that start import. Then first-class PySpark Diagnostics. A lot of people consider Databricks to be the Spark company, and as expected, a lot of our users do use PySpark very commonly. But like a typical thing that might happen is that you write a long data pipeline, you run it, you wait for a long while, maybe this thing runs for multiple hours, and then you get to the final point where you have a select statement, and your code crashes because you forgot a letter, or like you mistyped the column name. Well, it would be nice if we could prevent that and give you a signal that, hey, you miswrote the column name early on, and this is where syntax error highlighting comes in handy. Because we have that data frame in memory, we can check, hey, these are the columns that are present in this data frame, and we can give you much more accurate lints, thus preventing this very frustrating scenario, which happens quite often. Dynamic sys.pat aware definition request. So this is getting a little bit more niche now, but the idea here is that you can modify that sys.pat directly in a notebook, and what that does is that can change how your imports are resolved. So in this example, wait for the visualization to restart. But in this example, we have some path in our sys.pat. We have this import. We do a coded definition. We see it resolves to this file. The answer to the ultimate question is 41. Then we update our sys.pat. So now the import is going to resolve to a different file. And we can see that it does resolve to the correct file. We do get the correct answer. And this is only possible because we're able to update the sys.pat dynamically inside of the language on the language server side as well. So when we're resolving imports to reply to that go to definition requests, it gets the most up-to-date state. Now, there are other advantages that we get from being kernel embedded besides just being runtime aware. So first example is that we sync our entire document to the language server, not just the individual cells, and that gives us a bunch of cool benefits. So the first one is hybrid static dynamic autocomplete. So I believe by default, Jupyter only, when you send a completion request, it only looks at the contents of that current cell. But because we are aware of the entire document state, and we are also aware of what other variables are in memory but might not even be defined in code anymore, we're able to give you a more complete autocomplete suggestion list. Then we can give you lints that are cell order aware. So for example, in this case, we have a cell that references a variable foo, but foo itself is defined in a subsequent cell. Now, you could execute cells out of order and everything will work. However, if you just press run all or something like that, this will fail because by the time that the second cell is executed, the fourth cell has not yet been executed. So instead of just showing you the typical undefined variable lint on line 2, we can do better and say, hey, this variable is defined, but it's defined in a subsequent command in cell 4. And then, taking a step further, we can even give you a quick fix action that lets you instantly bring that definition cell up above your above the cell where this variable is defined, thus putting your notebook in like a more consistent state where it can easily be rerun. Then we have best effort syntax error highlighting. So typically, if you take a full bit of source code and pump it into a tool like Rough for syntax error highlighting, if it encounters some serious syntax error, such as like a partial function definition, then the abstract syntax tree that it's parsing is going to be broken, and it won't be able to reliably give you any lints for any of the subsequent code. Which kind of sucks, because if you have a cell with a syntax error highlighting on syntax error on like at the very top of your notebook, then all the subsequent cells by default would otherwise not get any lints. But because notebooks are broken down into these like nice cell blocks, what we can do is before we send our document to Rough for analysis, we go through each of the cells individually and we do a very simple AST parsing to see, is the syntax in this cell valid? And if the syntax is not valid, then we kind of just like comment it out and at least send the rest of the document to Rough. So you won't get any extra syntax error highlighting for that cell, but you'll still get syntax error highlighting for all the subsequent cells. And then finally, one of the nice things we do at Databricks Notebooks is that we preload a bunch of globals. So for example, Spark and get IPython are very commonly used things by our users. So instead of forcing the user to import them manually at the top of every notebook, we import them automatically. However, because those imports don't exist in the notebook document itself naturally, if you then send that notebook content into Rough or some other linting tool, it will fail because it isn't able to resolve that symbol. But since we are aware of this, what we can do is essentially prepend those imports before sending the contents into some of the tools, and then when we get back the responses, we just have to essentially offset all the line numbers by 1 to make up for like the import line that we inserted at the very top. Then there are benefits that we get from being kernel embedded. First one, the big one is document standardization. So by default, a lot of these linting tools like Rough, they don't know how to handle IPython magics, so cell magics and line magics. So if they see something like %% time it might just error out. So the workaround for that is before sending the contents to linting, once again, just comment out those cell magics. And originally, we just had a bunch of regexes to detect these, and we did that manually. But there were a couple of edge cases that we didn't catch, and that caused problems. However, because we are embedded in kernel, we can actually pull in the exact same function that IPyKernel itself uses to handle these magics and detect these magics. And we use that exact same transformer no matter what even if the kernel version gets updated or something like that, or that logic gets updated, we will always be up to date, and we can always use the exact same logic for detecting the magics, and then just given a custom transformer that just comments the magics out instead of doing anything fancy. Cool. So those are some of the cool examples of what we've built so far, but as with most things, it hasn't been completely smooth sailing to get to this point. So here are some of the key challenges that we've faced. First of all, comms handling. We sent these LSP messages as special Jupyter messages, and by default, Jupyter messages are usually sent on the shell channel. Now, problem is that shell channel message processing is usually blocked by cell execution. Well, maybe not in IPyKernel 7.0 and above with a new shell channel message processor. So this is something that we might be able to revisit and improve once we upgrade. But before 7.0, that would mean that if you send these messages on the shell channel, then as long as your cell is executing, suddenly you don't get any syntax error highlighting updates. You can't use any of the IDE features like quick fix actions or go to definition and all that. And that would kind of suck. So the solution for that was, instead of using the shell channel, we opt in and started using the control channel instead. Kind of not ideal. But because the language server runs in a separate thread, if we see any of these LSP messages, we just instantly hand it off to that language server thread in order not to block any of the other critical messages that actually use the control channel. For example, interrupt requests. And talking about interrupt requests, that poses another problem. So usually when the kernel gets an interrupt request, it SIG kills the entire process group. Which kind of makes sense. Like you have a cell that spins off some sub-processes. If you interrupt and cancel the execution of that cell, you want to probably kill those sub-processes as well. However, we run our linters and all these other LSP tools also in sub-processes. And originally, those would also get killed if you if you canceled the cell execution. Once again, not the greatest user experience. So the way around that was actually quite simple. We just run all those tools in sub-processes in a separate process group. Then ensuring kernel stability. So for us, it's very important that a lot of our users write their data pipelines in notebooks and then schedule them. And once a notebook is scheduled, it should keep on running no matter what. And what we don't want to do is we want to avoid the situation where we're trying to ship some new exciting interactive feature, like a new linter tool or something like that, and then that upgrade or that process ends up breaking the actual execution side of things in cells, and suddenly like, your long-standing jobs that have been running for 3 years without an issue break. So for that, it's very important for us to maintain that isolation between the kernel and the language server, which is why it's in a completely separate thread with proper error handling. And even though you could just import like globals and other stuff from the language server code base in the kernel body itself, even just importing code can cause big problems. So in order that, we have linter rules and other stuff in our own code base that explicitly prevents that, and you can only access, or like the kernel can only talk to the language server through one specific messaging path. Cool. And then managing dependencies. Most of these tools like Rough and Pyrite, they're actually just Python packages themselves, which is great. And we want to run the tools in the same Python environment as the user because that gives cool possibilities, like the user can upgrade these tools. Like if they want to use the newest and latest version of Rough that we aren't shipping with yet, they can just pip install Rough, and we will start our language server will start using that newest, greatest tool. However, users can also modify the environment. So it's a double-sided sword. So one of the things that we see is some users at the beginning, when they're spinning up their compute, they just completely wipe the Python environment that we ship with so that they can install only the packages they want from a clean slate. But the problem was that in that case, they will also wipe all the nice language server tools that we ship with. So the solution to that is we actually do ship a separate Python environment for DBLS as well. But then we have tiered tool discovery, where we first try to see, hey, is Rough available in the main Python environment? If yes, awesome, use that. If not, then at least we have a fallback. Then because our language server is embedded in the kernel itself, it does create this dependence on compute availability. In Databricks, you can create a notebook and you can edit it and all that kind of stuff without it actually being connected to a kernel and compute engine instantly. So that means that you can end up in a situation where you don't have a compute, so you don't have a kernel, you don't have a kernel, so you don't have a language server. There are some things that we're looking into to improve this, but right now it is a bit of a downside. And then finally, IO pub pollution. So IPython pretty eagerly sends all logger outputs to the IO pub channel, which then ends up being propagated to like the cell output. But logs from our language server internals or any of the various LFP tools that we call can thus end up polluting that IO pub channel, and we don't want user cell execution to have like random logging messages from our language server or like errors from Rough or anything like that. So the solution for that is we have a custom output stream that suppresses the language server thread standard out and standard input from being published to that IO pub. So this is where we're kind of at today. It's a pretty popular language, I would say, among our users. I'm quite proud of what we built, but there's always more to do. So first of all, this is a call out to all of y'all as well. I think we should build more runtime/kernel-aware language server features. So try to think about like what other like lints or formatting or something that could benefit from being aware of the runtime state, being aware of the memory state, being aware of the full notebook document. I was brainstorming yesterday, and just off the top of my head, a couple of ideas that I got were, well, we have runtime-aware lints for PySpark. Let's add it to pandas. Stephen was talking about reactive kernels and reactive execution kernels. It's important. In some of them, it's if you redefine a variable, that can break reactivity. So maybe we could provide warning lints in those cases. You can imagine that you have your notebook, you've pip installed some packages, you've imported some packages, and now you want to ship your notebook to someone else. Well, because we know exactly which packages have been imported actively, we could write you a requirements file and like freeze whatever your current package dependencies are that you've imported in your memory state, so that you can kind of like ship whatever is actively in your computer right now. Another code action for like if you've referenced a package in your code that is available in sys.path but you haven't imported yet, well, we know what packages are available in sys.path, so we could offer you an automatic import, and so on. Then, second of all, I think we should expand the LSP or like language server protocol and add new message types to provide this runtime info, not just for language servers, but for any other tools outside of language server as well. The main use case here would be AI agents, which would definitely benefit from having access to this runtime memory state goodness. So I think we should expand the protocol so that agents can send message to the language server to get back information about, hey, what's the current state of the kernel? And then besides just language server tools, I encourage everybody to think about other what other developer tools could we build to be notebook native. So think about what IDE or developer tools you use when working outside of notebooks today, and then how could those tools benefit from the notebook environment? Or how would those tools need to change and adapt to be relevant in a notebook environment / reactive REPL execution environment? And once you have some ideas, go and build them. With that, that's the end of the presentation. Thank you, and I'm open to any questions. Yep.
I'm going to throw you a softball. So let's suppose I have like a type checker, right? If I pip install a package that I didn't have before, like requests, would I automatically start getting the correct type checking lints as a result inside of Databricks language server?
Yes, because when you pip install it, it installs in the same environment that the language or DBLS is aware of. So it will be now able to resolve those packages and those imports through the updated sys.path environment.
Very cool.
Yeah.
I was wondering how far you want this link to go. Like if I define like a function that can only accept like integers greater than 5, would you like have like a linting warning saying that you're trying to find a value that isn't in this function?
Yeah, okay. So the question is, how far do we want to go? For example, if you define a variable that should only, if you define a function that should only accept integer input of value greater than 5, would we provide lints for that? Why not, I would say. I don't know. Well, I guess it's like in your function, you could have an assert or something that to check at the top, like verify the values of your inputs. I don't know if in Python there's a way to have that in your vanilla Python, if there's a way to add those constraints to your inputs. But if there's like a standardized way to do this, or just a way that we support as that we promote as a platform to do this, then why not? I think in general, a lot of these tools like Rough are built for standard Python nowadays. But the reality is that if you're working in Jupyter notebooks, for example, there's a bunch of extra syntax and conventions that are only relevant in this environment. If you're working in Databricks, there's a bunch of other conventions that are relevant for Databricks, and so on and so on. So I think this idea of expanding these linter tools is great for every platform. If it's big enough that it's worth it, we should provide users the most accurate, best information as soon as possible. Thank you.
I forgot to say earlier, this was a really nice talk, Tim. Thank you so much for preparing it. One other question that I had: are there any gotchas that we had to consider for like multi-user collaboration use cases?
Yes. I mean, point to different ones. The first one off the top of my head is that the way we sync to document content is, even though the language server runs on our node, which also has access to like the actual file, because the file is synced through like a network file system and all that, there's a little bit of delay there, and we don't want the situation where a user adds a character in their cell, and then it takes like a 6-second sync trip for the syntax highlights to update. Whenever the user updates their cell, we send the update document, the document update contents to the language server directly. Now, in a multi-user situation, you can see how that could become problematic, where multiple people are editing different cells, so there's a little bit of complexity there to make sure that everything stays in sync. Besides that, probably other things, but nothing off the top of my head. But there were surely other things, yes.
Yeah, I think one of the tricks that we did was we actually create a new document in the back end for each like distinct browser tab, and that helps prevent like lints from ping-ponging around. Yeah.
So it's like every user has their own corresponding URI for that document within the language server. Yeah. Cool. Yeah.
It's probably like a dumber question. This is all very new to me. So let's say I did want to tackle something where like I wanted a cell to get highlighted like a color, like a variable in that cell was used like or changed previously or something. Is the approach to do that just like HTML, CSS? Like that's the part that went over my head. How would I start tackling this? What tools would I use?
Yeah. So it depends on what are you using as your code editor. So for at Databricks, we use Monaco, which is the core library that powers like VS Code. And Monaco has like a pretty open API for like every editor has a URI, and you can essentially just send messages to the Monaco like kind of like server that's running and say, hey, for this URI, I have these diagnostics. And then Monaco will handle the rendering part. So what we need to do is just make sure that we send those messages appropriately. So the way we do it is we take the contents of the document or the cell, send it to Rough, which is a tool for linting. Rough gives us back a report that says, it's usually in JSON format or something like that, where it says like, okay, on this line, from this character to this character, there's a syntax error, and here's the description. Then we take that, transform it to like the Monaco format, and then do some post-processing. So for example, we'll see that, okay, on this line, there's an undefined variable function. On this line, there's an undefined variable error. But then we check the memory, say, we see that this memory does exist, this variable does exist, but only in memory. So then we just override the error message for that syntax error highlight and update the code so that it shows that like this is a Databricks Databricks generated error instead of a Rough generated error, and then we send it to Monaco to render. So there's like a nice separation. I think Jupyter notebooks might use a different rendering engine.
They use code mirror still, but there's talks to I think move to Monaco at some point. It's going to be a long haul though.
Yeah. but I would imagine that Chromium also has some sort of API for displaying syntax error highlights.
Yeah.
Yeah.
Are you also doing LSP for SQL?
We are, but our SQL LSP is, I think, believe almost entirely front-end run right now. So right now we have like separate handling essentially. Like we use DBLS for Python. We use all the front-end stuff built by another team for SQL. But I believe there's opportunities in the future to combine. All right. With that, thank you.